The more we learn about the universe, the stranger it becomes. Over the last century, astronomy has transformed our understanding of reality. We've discovered billions of galaxies, photographed black holes, detected gravitational waves, and even found thousands of planets beyond our solar system. Yet despite all of these discoveries, some of the biggest questions remain unanswered. What is most of the universe actually made of? What happens inside a black hole? Why is the universe expanding faster and faster? And could the answers completely rewrite the laws of physics as we know them? These are the greatest mysteries in astronomy. Look up at the night sky, and everything you see, every star, planet, nebula, and galaxy, is only a tiny fraction of what exists. Astronomers estimate that ordinary matter makes up only around 5% of the universe. The remaining 95% appears to consist of two mysterious components known as dark matter and dark energy. Dark matter cannot currently be seen directly, because it does not appear to emit, absorb, or reflect light. Instead, scientists infer its existence through gravity. Galaxies rotate far faster than they should if only visible matter were present. Galaxy clusters bend light from distant objects more strongly than expected through gravitational lensing. Computer simulations of galaxy formation also match observations far better when dark matter is included. But despite decades of research, nobody knows exactly what dark matter is. Scientists have proposed many possible particles, including WIMPs and axions, but none have yet been confirmed. One of astronomy's greatest mysteries is that most of the matter in the universe may be completely invisible. In the late 1990s, astronomers studying distant exploding stars made an astonishing discovery. The expansion of the universe is accelerating. Instead of gravity gradually slowing everything down, galaxies are moving away from one another faster and faster over cosmic time. The simplest explanation is something called dark energy. Unlike dark matter, dark energy does not appear to clump together around galaxies. Instead, it seems to act across space itself. Today, dark energy is estimated to make up roughly 68% of the universe. But what it actually is remains unknown. It could be a property of empty space, known as the cosmological constant, or it could point towards entirely new physics beyond our current theories. At the moment, astronomers simply don't know. Remarkably, most of the universe appears to be made of things we still cannot fully explain. Black holes are among the most extreme objects ever discovered. Their gravity is so intense that once something passes the event horizon, not even light can escape. General relativity predicts that matter continues collapsing towards an incredibly dense region called a singularity. But quantum mechanics, the theory describing the smallest scales of nature, breaks down under these conditions. This means our two greatest theories of physics cannot currently describe what truly happens inside a black hole. Some ideas suggest singularities may not physically exist at all. Others propose that quantum gravity could replace them with something entirely different. There are even hypotheses involving wormholes or information being preserved in ways we do not yet understand. At present, no observation can tell us which, if any, of those ideas is correct. The true interior of a black hole remains hidden behind one of nature's ultimate barriers. Nearly every large galaxy appears to contain a supermassive black hole at its center. Some contain billions of times the mass of our Sun. The mystery is not simply that they exist, it's that some of them existed incredibly early in cosmic history. Astronomers have observed quasars powered by enormous black holes less than 1 billion years after the Big Bang. Growing something that massive in such a short time is difficult to explain using standard models of black hole formation. Perhaps the first black holes formed directly from enormous clouds of gas. Perhaps they grew much faster than expected, or perhaps our understanding of the early universe is incomplete. Whatever the answer, these ancient giants continue to challenge current theories. The Big Bang is often described as the beginning of the universe, but that description can be misleading. The Big Bang theory successfully explains how the universe evolved from an extremely hot, dense early state. It does not necessarily explain what, if anything, happened before that state. In fact, according to general relativity, asking what happened before the Big Bang may not even make sense if time itself began with the expansion of the universe. Other theories suggest the Big Bang may have emerged from an earlier quantum state, a bouncing universe, or something even stranger. At present, there is no observational evidence that confirms any of these possibilities. The true origin of the universe remains one of science's greatest unanswered questions. For most of human history, we knew of only one planet capable of supporting life. Today, astronomers have confirmed thousands of exoplanets orbiting distant stars. Some appear to lie within regions where liquid water could exist. Future telescopes may even detect molecules in their atmospheres and could hint at biological activity. Yet despite the sheer number of potentially habitable worlds, humanity has never confirmed evidence of life beyond Earth. This leads to the famous Fermi paradox. If intelligent life is common throughout the universe, where is everybody? Perhaps intelligent civilizations are incredibly rare, perhaps they are separated by distances too vast to communicate, or perhaps we simply have not looked long enough. Until evidence is found, the question remains open. In 2007, astronomers identified an extraordinary phenomenon. A burst of radio waves lasting only milliseconds had travelled across billions of light years before reaching Earth. Since then, hundreds of these fast radio bursts, or FRBs, have been detected. Some occur only once, others repeat unpredictably. Many astronomers think at least some FRBs are produced by highly magnetized neutron stars called magnetars. Several observations strongly support this explanation. However, not every detected burst fits neatly into the same picture. It is possible that multiple different astrophysical events are capable of producing similar signals. Exactly how all fast radio bursts originate remains an active area of research. Measuring the expansion rate of the universe sounds straightforward. In reality, it has become one of modern astronomy's biggest puzzles. When astronomers calculate the expansion rate using observations of the early universe, they obtain one value. When they measure it using nearby galaxies and exploding stars, they obtain another. Both methods are extremely precise, yet they disagree by more than expected. This disagreement is known as the Hubble tension. It could be caused by subtle measurement errors that have not yet been identified, or it could be evidence that our current model of the universe is incomplete. If the latter is true, it may point towards entirely new physics waiting to be discovered. Astronomy constantly pushes physics into environments impossible to recreate on Earth. The hearts of neutron stars, the edges of black holes, the first moments after the Big Bang. These are places where our current theories are stretched to their limits. Physicists continue searching for a theory that unites general relativity with quantum mechanics into a single framework. Candidates such as string theory and loop quantum gravity attempt to solve this problem, but neither have yet been confirmed experimentally. If a successful theory is eventually found, it could completely transform our understanding of space, time, and reality itself. Although these mysteries remain unsolved today, astronomy is advancing faster than ever before. New observatories on Earth and in space are allowing scientists to observe the universe with unprecedented precision. Gravitational wave detectors are opening an entirely new way of studying violent cosmic events. Powerful radio telescopes continue discovering mysterious signals across the universe. Future missions may reveal the atmospheres of Earth-sized exoplanets, discover the true nature of dark matter, or uncover clues about the earliest moments of cosmic history. History has shown that every major breakthrough in astronomy raises new questions alongside new answers. The next great discovery may arrive when we least expect it. Astronomy has revealed a universe far larger, older, and stranger than anyone once imagined. Yet for every mystery we've solved, even greater ones have appeared. Most of the universe seems to be made of substances we still cannot identify. Black holes hide their deepest secrets behind event horizons. The true beginning of the universe remains uncertain, and somewhere among the countless stars, life may or may not have emerged again. Perhaps that's what makes astronomy so captivating. It reminds us that humanity's greatest discoveries are not the end of the journey. They're simply the point where the next mystery begins. The universe still has countless secrets left to uncover, and somewhere out there, the answers are waiting. Thank you for watching this video. I hope you enjoyed exploring the greatest mysteries in astronomy. Let me know if you have any theories on how these mysteries could be solved down in the comments. Make sure you hit the subscribe button, and if you have anything you would like to explore with me in a future video, I will do my best to make that happen. Stay tuned for the next video where we talk about more of the strangest planets in the universe, and as always, stay curious.